In this quantitative comparison question, we're given this quadratic equation, and the writers actually want you to notice that it is quadratic in 6x, meaning if you called 6x another variable, say z, this is equivalent to z squared minus z minus 12 equal to 0, which is a lot easier to solve as opposed to simplifying this quadratic. And I'll show you that approach too, so that would require you to square that first term, minus 6x minus 12 equal to 0. Divide both sides by 6. We would get 6x minus x. Sorry, this is 6x squared minus x minus 2 equal to 0. This is a much harder quadratic to solve. And I'll do this towards the end as well. But the key idea that the test writers want you to see is that this is a quadratic if, and a lot easier to solve if you define this a new variable. This becomes one of the standard quadratics that can easily be factored. And the two numbers here are going to be 4 and 3. We need a minus 1 here. So this would be minus 4 plus 3. And z really stands for 6. So this is equivalent to 6x minus 4 times 6x plus 3. This piece tells us 6x plus 3 is 0. 6x is minus 3. X is minus half. But we're given that x is positive. So this solution is not acceptable. The first one, 6x minus 4 equal to 0, gives us 6x is equal to 4. X is 4 over 6. Reduce this 2/3. So x is 2/3, and because we're told that x is positive, the value of x is 2/3. And 3/4 is greater than 2/3. So the correct answer is quantity B. Now, if we were to go this route, which is longer, is we would have gotten to this stage, and to solve these, the quadratics that have a number in front tend to be the hard ones. And the way I do this is a little bit different as opposed to the trial and error method that we did here. It's a little bit harder when you have a number in front. As you think of two numbers, that would give you a product of minus 12. So what you do is you take these numbers, 6 and minus 2. We need to think of two numbers that give a product of minus 12, and then they add up to the coefficient of x, which is minus 1. So I need two numbers that would add up to minus 1. Their product is minus 12. And those numbers are minus 4 and 3. So you use that, and you split this. Basically, all you're doing is rewriting the middle term, because this is really minus x. Then you factor common terms from the first two. So here 2 is common. We got 3x minus 2. And nothing can be factored here, so you just write, actually I need to factor 2x, because this is 6x squared and 4x. So it's 2x times 3x minus 2, and then this is 3x minus 2 equal to 0. Then we factor out 3x minus 2, the entire expression. And then we get 2x plus 1 equal to 0. This one gives us x equal to minus half, which is again not acceptable, and this gives us 2/3. So this was the second approach, but this is the longer approach, and I think that's what the writers, this is the direction they want you to go. It's much harder to implement. So look for the standard quadratic forms on the questions on the GRE.